In this session, let's look at sets in Python. A set has values that are not in order and does not return duplicates. It looks similar to a list data type and a tuple data type. Recall from the previous sessions, a list is created using square brackets, while a tuple is created using parentheses. There are three ways to create a set. In the IDE, the first way is by using the set function. Women equals set. Then we add parentheses. Within the parentheses, we add square brackets. And the second way is using the set constructor. Men equals set, followed by parentheses. This time, we add more parentheses inside the parentheses. The values for women will be Janet, Jane, Jazz, and we're going to add Jane one more time. The values for men will be Joe, John, followed by James two times. So we have duplicate values for men and women. Print the women values and also print the men values. When I run, notice that the values are not in order how I added them to the set and does not contain duplicate values. Women does not contain duplicate value Jane, and men does not contain duplicate value James in the console. The console starts with Janet for women and James for men. If I keep running, the order will change each time. This time it shows Janet and Joe, Jane and Joe, Jazz and James. The third way of creating a set is by using a literal. Do you see how the console shows the values inside curly brackets? We create set literals using curly brackets. The brown background for women and men says function call can be replaced with set literal. Let's write numbers equal curly brackets. Within the curly brackets, write values 1, 2, 3, 4, 5, 6, 7, 8, 9, 2 times. Then write 10. So the duplicate values are 9 and 1. Now let's print the numbers. When I run, the console shows an error because I did not add the S for numbers. Now we see values 1 through 10 in the console without a duplicate number that was returned for numbers. Also, a set does not support indexing. If I write square brackets, then add 1 for the index number, then run, we see type error with a note that says set object is not subscriptable. In previous Python versions, this type of error had a note that said set object does not support indexing. The error shows up because we are not able to access an item since there is no sequence order. For the set data type, we can check for a value or collection of values using built-in functions. Let's start by creating some new set data types like even numbers, odd numbers, and prime numbers. For evens, they will equal curly brackets 2, 4, 6, 8. Let's go ahead and add 0 also. And for odds, they will equal curly brackets but start with 1, 3, 5, 7, and 9. Prime numbers, they will equal 2, 3, 5. I almost forgot the prime numbers. 2, 3, 5, 7, and 11. Now, a prime number is a whole number that only has 2 factors. The two factors are 1 and itself. Also, they can only be divided by 1 and itself. 1 is not a prime number because it only has one divisor. The first built-in function we are going to look at is union. A union combines two or more sets, then return a new set. Let's write evens dot union, then pass in odds. This statement will unite the even numbers and odd numbers. Print, then run, and the console shows numbers 0 through 9. If we do not want to add the word union, then we can write a vertical line symbol that represents union. Odds, vertical line symbol, evens. Print, then run. We see 0 through 9 for both statements. The intersection function is another built-in function. It helps to return a new set when two or more sets have a value in common. Let's look at the even numbers and the odd numbers. The even numbers are 0, 2, 4, 6, and 8. The odd numbers are 1, 3, 5, 7, and 9. Therefore, they do not have a value that's common. So if I write evens dot intersection, then pass in odds, print, we're going to see what the console returns. As expected, an empty set value. Now, as expected, it's empty because there are no common values, but the prime numbers have common values with even numbers and odd numbers. 2 is the only even number that's also a prime number. 3, 5, and 7 are the only odd numbers that are also prime numbers. To see even numbers that are prime numbers, let's write evens dot intersection, then pass in primes. Now, to see the odd numbers that are prime numbers, we can use an ampersand symbol, which represents the intersection function. Odds and primes. I'm going to print the sets for both, and we're going to see what the console returns. Run, and the console shows 2 for the even number and 3, 5, 7 for the odd numbers. There are more built-in functions that we can look at, but let's look at one more function. How about the difference function? It returns a new set after checking the difference between two or more sets. For example, the prime numbers are 2, 3, 5, 7, and 11. Now look at the odd numbers, 1, 3, 5, 7, and 9. 2 and 11 are numbers that are not in the odd number set. Therefore, the process will look at the prime numbers, then check to see which numbers are not in the odd number set. Let's write primes dot difference, then pass in odds. Print and run, and the console shows 2 and 11 as expected. Now, let's switch it around and look at the odd numbers 1, 3, 5, 7, and 9. What's the difference between odd and prime? 1 is not a prime number and 9 is not a prime number. Let's print the difference by writing odds minus prime. The minus symbol is a shortcut for writing difference. Print and run. The console shows 1 and 9 as expected. That's it for Python sets. Thanks for watching, and I will see you in the next session.